I'm very pleased to give you your first midterm assignment. Midterm. And this midterm is going to be a tic-tac-toe playing robot. Now, problem statement P. Program the robot to play tic-tac-toe with human. Now, I'm going to give you process step by step. And I want the robot. So, the step number 1, first, once you press the button or once you press the key on your computer, first, the robot should draw the grid. And this is drawing. So robot should draw the grid, which is exactly similar to your first lab, where you will specify the coordinates and the robot will draw the grid. Second, then you should play with the human operator, which means the human operator or human draws crosses or zeros. So you don't know whether if someone is gonna draw cross or someone is gonna draw zero. Then third, so here this is the human goes first. So human goes first. Then DoBot sees where the human has drawn, whether it's an X or whether it's an O. So if the human has drawn X, the robot should draw O. If the human has drawn 0 or O, robot should draw X. And the code should intelligently tell the robot where to draw it, which means, so basically, as you know, and this algorithm you can find the algorithm using ChatGPT or MATLAB code, or it can be a rule-based system. So basically, it's a 3x3 grid. You can actually create a rule-based system that tells robot what should be the next position. Then once it is drawn, human goes next. And then the robot goes next. And then at the end, if the robot wins, so something like this, then robot should draw a horizontal line indicating the win. So robot win. If it's a draw, then robot basically should indicate it's a draw. So the robot could indicate. So for an example, if you finish a horizontal line or vertical line, the robot should draw horizontal or vertical line. So, and so if it's draw or inconclusive, then probably robot can sign something like T or something like that. On the side, it should indicate it's a draw. Everyone understood this? This is the basic assignment. That is going to give you 10 points. Next part is the bonus, B1. In bonus B1, you should be able to handle the edge cases. Which means, think about that if the human edge cases means you should give an option whether the robot goes first, or human first. So for an example, in your program, you can ask for a prompt. So when the program starts, first robot draws the grid. So this is robot draws grid and then waits and asks who first. And you have two options, either the robot or the human. So the user can enter H, then human has to draw and the robot will wait till the human draws. So human has to draw and robot has to wait for human to complete the drawing. If you see R, if you give prompt for R, then the robot should draw. Robot should draw X or O's. And then the game continues. So here, for the bonus part, you would add an option whether the robot goes first or the human goes first. The basic assignment is always you would start with the human will draw, the robot will draw, and at the end you will compare. The edge case, you will give an option, first option, robot or human. You should treat this edge case. This will be 5 points bonus. So let me show you here. This is going to be 10 points. This will be 5 points. B2 and B1, B2, B3 are totally optional, okay? If you don't want to do it, you don't have to do it. But if you want to get an A+, I strongly recommend you do these. Second edge case, edge case 1, edge case 2, is human starts and human draws at 2 locations. So draw at 2 locations. Draw 2 locations. Then the robot should throw an error. Maybe it should say E or something like that. It should just write E on the side. Or it should give a prompt error on the computer screen. So this is error. Second edge case is now you start and the human is supposed to cross. Human ideally is supposed to cross, but by mistake or by intent, human makes mistake. And instead of X, that human draws O. So it should throw an error. This part is again 5 points. Everyone understood? The first edge case is you have an option for the robot to go first or for the human to go first. Second option, second edge case is you handle errors. So human makes a mistake. So there are 2 errors that are possible. Like the human, instead of drawing 1, the human draws at 2 or more locations. You can draw at 2 or more locations. The robot should throw an error. Or humans is supposed to cross, but the human circles. So it should throw an error. If you handle edge case number 1, which is bonus 1 and bonus 2, then you would get 5 and 5, 10 points extra. Do you agree with me? B1 and B2, this is individual. So this is individual. So which means your midterm B1 and B2 is individual. And the last, which is C, you can work with 1 more person and then 2 dobots should play against each other. And this is a group assignment. Only 2 people are allowed. If you successfully finish part, so before you go to part B or before you go to part C, the midterm needs to be complete. So if you do your midterm, then you can actually go for B1 and B2. And if you are satisfied with your B1, B2, then you can partner with 1 more student, and then basically your do-ball to play against your friend's do-ball. Everyone understood this? Yeah.
For B2.
Yeah.
Is that human error happening mid-game or at the very beginning?
Anytime.
Okay. So the basic midterm said that human can draw either one first. The robot has to recognize that, right?
Correct. That is the part 1. Part A, that you need to finish. This is required. This midterm is required. So before you do either B1, B2, and C, your midterm has to be complete. Everyone understood this? In terms of time, this big robot is a fantastic project, and you can make, depending upon how good you are in data structures and algorithms, you can write very, very efficient codes that can give you the solution. People have actually worked on chess playing robots, and they work on the same principle. But tic-tac-toe is something that we can start with. Any questions about the midterm? Okay. Typically, this part should not take more than 4 hours for you to finish. And then the remaining part, this part, should not take more than 4 hours to finish. And the last part, if you choose to work on it, should not take more than 4 hours to finish. Which means you would get 2 weeks to finish your midterm. Does that make sense? So you have 2 weeks to finish your midterm, and I would actually give you the requirements, like you need to submit a report, you need to submit your code, and you need to submit a video. And I will actually put this in a canvas. So report, a short report, not more than 2 pages, code and video. And remember, we have 3 graders. So they will check everyone's assignment before you get any grades for the part. They will make sure that you need to check out. So again, just like every lab, check out. So if your checkout is successful, only then we will give you the grade for the lab. Basically 10 points for the first part, 10 points for the second bonus, 10 points for the last part. Everyone understood this? Any other question before I begin? Yeah. Any? Can we prepare any course? Of course, you will have to prepare a course and come prepared. If you come to lab and expect that you will develop the course in the lab, that's not really possible. Every lab is an exam. This is an opportunity to train yourself to work under pressure. When you go to industry, you will not have infinite amount of time. You will have to deliver, you have to work under pressure. Robot is going to fail. There will be boss screaming at you. So take this as an opportunity to time yourself, manage your time, get disciplined, come to lab, prepare. And then even you are welcome to look at inspiration codes if people have done other assignments. So this is not like closed book, closed notes. You are welcome to use all the resources. But if you just write the code in ChatGPT, I can promise you it's not gonna work. So come prepared. Yeah. Come to the lab, finish lab 4, and work on the problem. And you can take as many weeks as you want. Any other questions? No questions? Okay, good. Have fun. Okay, now in today's class, as promised in last class, I'm gonna work out the forward and inverse kinematics for R perpendicular R parallel to R robot. I set up the coordinate system in last class, but I'm gonna work this problem again from scratch. Please understand, this configuration is exactly same as your DoBot configuration. So DoBot is R perpendicular R parallel to R. the first revolute joint is perpendicular to the second revolute joint. First revolute joint is perpendicular to the second revolute joint. And second revolute joint is parallel. So this is the first revolute joint. This is the second revolute joint. And then you have one more revolute joint, which is over here. So this is R, and this guy is your end effector. Remember the rules. What are the rules? First, Z-axis should pass through joint. Second, XN must intersect ZN minus 1. And third rule is you have to use the right hand coordinate system. So I'm gonna set up my coordinate system. First and foremost, my Z0 is like this. Then my Z1 is like this. My Z2 is in the same direction as Z1. And since end effector has no joint, I'm gonna assume my Z3 is something like this. So I have Z0, Z1, Z2, and Z3. Everyone understood this? Then I'm gonna assign my X1. Now can someone tell me, so this is X0, so X0. Now where should my X1 be? I have two choices for X1 and I will show you both. My X1 can go in this direction or my X1 can go in this direction. But remember, Xn, which is X1, must intersect Zn minus 1, which is Z0. So do you agree with me that if I want this sign convention to be true, this should be my X1? You agree with me? Everyone agrees I cannot have X1 going up. Because if I have X1 going up, it will not intersect Z0. It will be like parallel to Z0. It needs to be perpendicular. So intersect and perpendicular. So it needs to be intersecting and be perpendicular. Now, for consistency, I will call this as my X2. I will call this as my X3. So now I have in the triad, X's and Z's are decided. Right hand coordinate system. X, so this is your X, Y, which is the first finger, Z is the middle finger, X is thumb, first finger is Y, middle finger is Z. So X and you have Z. So can you agree with me that this is gonna be my Y0? Now I have X, I have Z. This guy is going to be my Y1. Now I have X2, I have Z2. This is going to be my Y2. I have X3, I have Z3. This is going to be my Y3. You agree with me? Now what I would do is I would assign theta 1, I would assign theta 2, I would assign theta 3. It's very important to note that these theta are considered positive. So the rotation, when you curl your fingers in the direction of rotation, the thumb is pointing in the direction of Z0. When you curl your fingers in the direction of rotation of theta 2, the thumb will be pointing towards Z1. Curl your fingers in the direction of theta 3, your thumb is pointing in direction of Z3. So that's why theta 1, theta 2, and theta 3, they are positive. Everyone understood this? Next, we have to find out the rotation matrix. The rotation matrix is 0R1. Rotation matrix has two parts. The first part is the projection matrix. The first part is the rotation matrix that needs to be multiplied with the projection matrix. And the projection matrix will always be projection of x1, y1, z1 on x0, y0, z0. So x1 is the next frame and x0 is the previous frame. So I want to find out the projection of x1 onto x0. No matter what problem we solve, our rotation matrix, you know, it's going to be cosine theta 1 minus sine theta 1, sine theta 1, cosine theta 1, 0, 0, 1. Do you agree with me? This is the standard rotation matrix for the rotation about z-axis. Since every joint, the z-axis is passing through every revolute joint, rotation matrix for every joint would be the same, which is cosine theta. So cosine theta 1 minus sine theta 1 and all zeros except for the third row, third column. Now projection of x1, can you see that x1 is aligned with x0? You agree with me? Means the projection of x1 onto x0 is 1. So this is 1. x1 is not aligned with y0. x1 is not aligned with z0. Do you agree with me? Now let's look at y1. Can you see in this case, y1 is not aligned with y0. y1 is aligned with z0. You agree with me? Can you see y1 is going in the upward direction? So y1 is not aligned with x0. y1 is not aligned with y0. y1 is aligned with z0. Since the direction of arrows, they are in the same direction, you have positive 1. Now let's look at the last part, z1. Can you see that z1 is not aligned with z0? z1 is not aligned with x0. z1 is aligned with y0. But can you see that the arrows are there? Which means I need to be assigning -1 here. You agree with me? Once again, this part is important. And why there is a minus sign? Because even though the Z1 is parallel to Y0, they are opposite to each other. That's why you have this negative sign. Everyone understood this? So the total rotation matrix is going to be the multiplication of the rotation matrix and the projection matrix. So when you multiply rotation matrix times projection matrix, first row, first column, cosine theta 1, first row, first column, first row, second column, first row, third column, second row, first column, second row, second column, second row, third column, third row, first column, third row, second column, third row, third column. Yeah. Okay. Yeah, you're right. Second row, third column should be minus cos theta. You're absolutely correct. Everyone understood this? Now, please note the rotation matrix after multiplying with the projection matrix maintains the same structure. We have cosine, sine, 0, 0, 0. If these two elements are 0, the last element is 1. First element sine, cosine, 0. I want you to look at the symmetry. Sine, sine, cosine, cosine. Everyone understood this? Rotation matrix. If you find the determinant of rotation matrix, can you see its identity? Remember the formula for determinant? If you find the determinant of the rotation matrix, it's an identity matrix indicating that the rotation matrix is an orthonormal matrix. How do you know it's an orthonormal matrix? For matrix to be orthonormal, determinant needs to be unity, and all rows and all columns must be independent. Which means you take any column and take its dot product with any row, it's going to give you 0. So that's why this matrix is called as orthonormal matrix. Okay, now what we need to do is we need to set up the homogeneous transformation 0H1. Now to set up the homogeneous transformation, I'm going to give you some values. And this is an opportunity for you to finish your lab 4 and part of your assignment 1 in class. Can someone tell me what is the value of A1 for the DuBot magician? Can someone tell me what is the value for A2 for DuBot magician? And can someone tell me the value of A3 for DuBot magician? If you have access to the CAD model or STL file, these values should be known. Alternatively, what you can do is when you go to lab, use a measuring tape and measure the values. A1, A2, A3. For homogeneous transformation, rotation matrix is going to remain the same. Zero, 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 and you have 1. Now there are 3 elements that we need to substitute. So once again, this guy, so again, please try to understand that here you are going to write down the location of frame 1 with respect to frame 0 about x0. So location of frame 1 with respect to frame 0 along x0, which is extremely important. Same thing for second one, along y0, along z0. Can you tell me? And right now, the only thing I want you to focus, please try to understand this. When you are finding out the last column of the homogeneous transformation, you should not be looking at x1, x2, and z2. You should not be looking at x1, y1, and z1. You should be only looking at x0, y0, and z0. So can you tell me what should appear here? What is this distance? 0. You agree with me? Because my frame number 2, my frame number 1 and frame number 0 are aligned along x0. My frame number 1 and frame number 0, they are aligned about y0. So can you see my y0 is also going to be 0. The only difference is my frame number 1 and frame number 0 are offset by a1. Do you agree with me? Now this a1 distance, it's extremely important. This a1 distance is in the positive z0 direction. You agree with me? You have to go up. So this a1 is positive. So positive a1. So 0, 0. You agree with me? This is going to be your first homogeneous transformation. Can we go to the second homogeneous transformation? So now I need to do 1 R2. The first part is very simple. You have the rotation matrix. This rotation matrix is not going to change. Multiplied by the projection matrix. Remember, you are going from frame 1 to frame 2. So you have x2, y2, z2. You have x1, y1, z1. Everyone understood? You are going from frame 1, you are going to frame 2. So this is frame 1, you are going to frame 2. Now 1 you are going to 2. And we have to find projection off. I will write down here. Projection off. So projection off. Off. And here, projection on. Rotation matrix, cosine theta 2 minus sine theta 2, 0, sine theta 2, cosine theta 2, 0, 0, 0, 1. You agree with me? Now tell me about the projection matrix. Can you see by observation? Now when you are trying to find the projection, right? right now what you should be looking at is you should be looking at frame 2 and frame 1. So this is your frame 2. This is your frame 2. And this is your frame 1. This is your frame 0. Can you see frame 2 and frame 1? They are aligned. It means projection of x2 on x1 is 1. Projection of y2 on y1 is 1. Projection of z2 on z1 is 1. Everyone understood this? So do you agree with me that the projection matrix is going to be an identity matrix? Any questions about this? And when you perform the multiplication, any matrix multiplied by the identity matrix is going to be cosine theta 2 minus sine theta 2, 0, sine theta 2, cosine theta 2, 0, 0, 0, 1. Now we have to write the homogeneous transformation 0h2. And when I write the homogeneous transformation, first I need to duplicate the same matrix cosine theta 2 minus sine theta 2, 0, sine theta 2, cosine theta 2, 0, 0, 0, 1, 0, 0, 0, and now you have 1. Now here, I'm going to rewrite this just for clarification. This is the location of 2 with respect to 1 along x1. Location of 2 with respect to 1 along y1. Location of 2, which is location of frame 2 with respect to 1 along z1. But it is extremely important for you to understand that this relationship must be valid for all the joint angles. I want you to look at the first homogeneous transformation, 0h1. You agree with me that 0h1 transformation is valid for all the values of theta 1. You agree with me? The relationship between the frame 1 and frame 0 does not change. The distance does not change. For theta is equal to 0, theta is equal to 90, theta is equal to 180, theta is equal to 360. Now, can someone tell me, I want you to look at the figure and tell me what would be the distance between the frame 2 and frame 1 about x1? It would be a2 cosine theta. Do you agree with me? Because when theta 2 is 0 degrees, that is the kinematic diagram. But if theta 2 is 90 degrees, then it will be completely flipped. It is exactly similar to the last problem that we got in the class. For the x distance, now I want you to understand that you have cosine and sine distances. So you have a2 cosine theta, a2 cosine theta 2, a2 sine theta 2, and what should be in the z-axis? 0. Do you agree with me? Any questions here? I would explain this one more time. I want you to understand. Imagine this joint, which is theta 2, rotates. when theta 2 is going to rotate, do you agree with me? The projection is going to be A2 cosine theta 2 about x1. Projection on y1 would be A2 sine theta 2. Everyone understood this? Any questions here? So the next part is you need to go to the next rotation matrix 2R3. The first part of the rotation matrix is never going to change. Second part of rotation matrix would change depending upon whether the coordinate system is aligned or not aligned. Same thing, projection of x3, y3, z3, projection on x2, y2, z2. You agree with me? Projection of x3, y3 and z3 on x2, y2 and z2. Can someone tell me what would be the rotation matrix here? Cosine theta 3 minus sine theta 3, sine theta 3, cosine theta 3. 0, 0, 1, 0, 0. You agree with me? Now, I want you to note that frame 3 is aligned with frame 2. Can you see that the frame 3 is aligned with frame 2? This is your Z2. Z2 is aligned with Z3. X2 is aligned with X3. And Y2 is aligned with Y3. See that? Which means my projection matrix is going to be an identity matrix. So 1, 0, 0, 0, 1, 0, 0, 0, 1. Now, when you multiply any matrix by the identity matrix, you get the same matrix. So 2H3 cosine theta 3 minus sine theta 3, 0, sine theta 3, cosine theta 3, 0, 0, 0, 1, and the last part is 0, 0, 0. You have 1 here, and then here, the distance between, so distance between frame 3 and frame 2 along x2, along y2, along z2. Can someone tell me what would that be? What would be the distance from frame 3 to frame 2? So frame 3 to frame 2. What would that distance be? A3 cosine theta A3 cosine theta, which is A3 cosine theta 3 A3 sine theta 3, and this distance is 0. Do you agree with me? Once this problem is set up, your forward kinematics is done. So if you want to find out 0H2, which is nothing but forward kinematics, find the location of end effector with respect to inertial frame. So you would do 0h1 multiplied by 1h2 multiplied by 2h3. Zero, yeah, 0h3. So 0h3 because 0 is the reference frame. Third frame is located at end effectors. So I need to multiply these three homogeneous transformations. Everyone understood this? And I'm gonna go to the same MATLAB script that we looked at last class. So please open the MATLAB script that I emailed you earlier. So we should have that MATLAB script. And what I'm gonna do is I'm gonna go to MATLAB. Go to MATLAB, open MATLAB, and then we will look at the script. Can anyone tell me what are the values of A1, A2, and A3 for DuBois? Okay, which means we can solve the assignment in class. Okay. So the first robot we already solved. Now I'm gonna go to the second robot. Line number 42. I'm defining the robot R perpendicular R parallel R. And I'm clearing all the variables. And the symbolic variables are A1, A2, A3, P1, P2, P3, theta 1, theta 2, and theta 3. Next line. Can you check my homogeneous transformation? 0h1 is nothing but h01 because MATLAB will not allow you to define a variable starting with number. You need to start with alphabet. So this is 0h1. This is 1h2. Can you see 1h2? And 2h3. You see 2h3? So these three homogeneous transformations, when I multiply, I get the forward kinematic solution. So if you want to run this forward kinematic solution, you can highlight this section, and run. And when you run the forward kinematics solution, the first part, first 3x3 matrix. So this 3x3 matrix, 1, 2, and 3. This 3x3 matrix defines the relative orientation between the frame 0 and frame 3. 1, 2, 3. This rotation matrix defines the rotation between the frame 3 and frame 1 in the reference frame of 1. Everything here is in frame 0. Everything here is in frame 0 because frame 0 is the inertial frame. So everything is with respect to the 0th frame. If you look at the last column, that gives you the forward kinematic solution. Can you see that the forward kinematic solution, this is Px, this is Py, and this is Pz. Do you agree with me? Px, Py, and PZ. Now what I do is, now since we know the values, I'm going to use the same sample values as the DoBot. Can you tell me what are the values? 407, 107, 1, 150, and 150. 1. So these are the values. Now I'm going to find the forward kinematic solution corresponding to these values. Everyone understood this? Now, ideally, the forward kinematic solution that you are calculating from this MATLAB script should be the same as forward kinematic solution that comes from the DoBot interface, provided the coordinate systems are aligned. You agree with me? As long as your x0, the DoBot x0 is aligned with x0 in our coordinate frame or kinematic diagram, if DoBot x1 is aligned with the x0 in the kinematic diagram, so your x0, y0, and z0, the zero coordinate frame should be aligned with the DoBot zero coordinate frame. It is highly likely that you will notice that coordinate system for the DoBot may not be the same as the coordinate system that we have used. Everyone understood this? And there might be a plus or minus kind of change. So when you work out the forward and reverse kinematics, what you should do is your kinematic diagram reference frame must be the same as DoBot physical robot reference frame. Everyone understood this? If your reference frames are not the same, the answers will not match, and that is extremely important. So I'm going to substitute these values and then find out the forward kinematic solution. So and then what you can do is you can substitute some angles, theta 1, theta 2, theta 3, and then you will actually, so let me highlight the script. I need to highlight this part of the script that gives you values, this equation, and this, and then this gives me the forward kinematic solution. And what I want you to do is, question? The code is a little different than my code. Yeah. OH1. Yeah. So our OH1 OH1, yeah, that is the same value. No? Okay. So this is the same value. That's okay. So you get this over here, and the next part of the code is trying to find the inverse kinematic solution. And what you're gonna do in inverse kinematics, is you are going to substitute the values that you obtained in forward kinematics. So here is how you should verify the answers in the lab. You should open the robot software interface, substitute the values for theta, theta 1, theta 2, theta 3. Robot interface will give you px, py, pz, and your robot will physically move that px, py, pz. The answers that you get from the MATLAB script should be the same answers that you should get from robot. A word of caution: the kinematic diagram is a representation of the physical robot. There is a small but non-zero chance that there could be some built-in constant offsets because of the hardware limitation. So when you compare, you need to take into account the hardware limitation, which means there might be some offset that you have not expressed in kinematic diagram, so that is present in robot. But I can promise you, you will get the exact same answers. Now, when you work out the inverse kinematics, you can actually find the inverse kinematic solution, run this script, and then if everything is correct, you should get the same angles that you substituted. So now, as I said in the last class, inverse kinematics may give you multiple answers. So what you need to do is you need to choose the proper values. So the way you would do it is theta 1, comma theta 2, comma theta 3. So once you do that, it should give you all the possible solutions for theta 1, theta 2, and theta 3. So now the forward kinematic solution, when you try to find out the joint angles corresponding to px, qi, and pz that we have specified, those joint angles can be one of these. You can achieve the same px, qi, pz with this three angles, same px, qi, pz with these angles, or these angles, and these angles. So what is the right angle? So many a times what you do is you perform something called as the workspace analysis, which means what are the most feasible joint angles, and then you pick up the right angle. Some of these angles may not be realizable. I want to give you an example. Think about DuBois. So you can see whether theta is equal to 0 is the angle which DuBois can attain. Whether theta 1 is equal to 180, that angle the DuBois can attain. So basically the DuBois goes all the way in the back. Then if DuBois can do theta is equal to 0 degrees, then you check the next angle. Can DuBois attain theta 2 is equal to minus 25? Or you will see if theta 2 can be 35. If both these angles are possible, then we will check the last angle. So you need to add those error corrections for if-else statements to make sure that those angles are achievable. Everyone understood this? This is actually your assignment, and then this also is your lab 4. So when you go to lab 4, make sure you have the script running, and the only thing that you need to do is you need to make sure your DuBois axis and the kinematic diagram axis are aligned, punch in the values, get the number, take a snapshot, and you are done with your lab. And you can proceed to work on your tic-tac-toe robot lab. Everyone understood this? So I think the regular sessions, you have one session today. There is one session after the class, and there are two sessions tomorrow, right? So which means almost entire class will be done by tomorrow. And then if you need extra time, they are going to open extra sessions on Wednesdays, Thursdays, and Fridays. Just pick one session, one slot. And when you come for the extra session, they will check that you attended your regular session. If you have not attended regular session, unless you have a valid university excuse, you will not be permitted for extra session. Just be fair. Everyone understood this? Any questions? If not, I wish you all the best. Make me proud. Let your tic-tac-toe playing robot win the match. Like